Hi everyone. The curiously recurring template pattern has many different use cases. It can speed up your code, it can provide nice abstraction, and it can also make your source code much cleaner. Today we will have a look at how CRTP allows you to extend the functionalities of your classes. We will dive into how you can reuse your code using CRTP and also where it does make sense to use this specific pattern. So come with me and join me in coding. To demonstrate what we want to do, I brought a small example. We have here a class, which is in this case called my class, and it basically consists of a member variable of a string, which is the name. So each object of this class will have a name, and the default for this name somehow is test. And we can do several things with the name. We can set it, we can get it, or we might even want to print it somehow to console and say my name is blah blah blah. Going to the console and compiling this, we will see that it's pretty straightforward and it's just printing out my name is test. As expected, my name is, and here we do have test. Now, since this is a quite common functionality that an object might have a name, we want to write this code in a way that it is actually reusable. So not only my class should have this property of having something like a name and all these functions that come with it, but any other class as well. So I want to be able to reuse that. Usually in C++ we have two ways of reusing stuff. So we can do it with inheritance, which is basically the is_a inheritance, or with a member, which is the has_a abstraction. So we try it out with normal is_a. So we write a new class, which in this case we call name, and the name of or the class name now has all these functionalities that we want to make general. So we have name, and because we want now to derive from that class, we also give it the virtual destructor, and we then have all the functionalities available, the set name, get name, the print, and we also have the name. Then my class can reuse this implementation by just inheriting from the class name. And here we can see we can now call set name as we would be able to call before. And in the main, it's basically doing the same thing. So we can instantiate the object and print it. So if we go to console and build this one, we see that the output is exactly the same. It's also printing my name is test. But there's a third way to do this. The third way is using the curiously recurring template pattern. So by making name something that in this case is now called named, and giving it the template type, which is from the derived class, I can use it to actually extend my normal class. And this is then done by using named as an inheritance, so as a parent class, with my class as the derived type. So in this case, named is not a real interface and not a real virtual class anymore. And you see this also because here is nowhere some virtual types or so, because the compiler already knows by the compilation time what type this named class will be. And by using that, you have now extended my class with all the functionalities that this named here offers. So you can use the set name function just as you would use any function that my class itself provides. Since you never plan on actually using the base class of this as a pointer, this is now really what you want to have. So you have a class which is extended by the properties, by the things that you can do with it, without paying for any overhead and also without having bloat in your source code and unnecessary source code basically. While the name example has been a little bit artificial and probably you won't do it like that in the wild, there are actually quite good use cases for this pattern. For instance, something that I have now prepared here is something for transforming objects. So for instance, objects that might have something like an origin in a 2D coordinate system. And this is something that you can really nicely extend your objects with without paying for the overhead that usually this kind of extension gives to your runtime. So here we have a simple origin 2D, which is implemented as a CRTP interface. So it also has the type name derived, and we also befriend derived because we want to access probably some private members of this class later on. And here we say we have a point which is an origin, so it's 2 coordinates, and we want to be able to translate the origin and also to print the origin. And this is now really a piece of code which can easily be reused to extend any object that you might have in your code by an origin. And for instance, if you have a triangle, you can say you want that your triangle is not just at a fixed position, but it can be translated through the space, and that's why you want to give it an origin. And the only thing that you need to do at this point is then to use origin 2D as a parent, and also use the triangle, so the class itself, as the template parameter to this origin. And at this point, all the functionalities that the origin brings you can be reused on triangle itself, just like with normal inheritance. And just to show that this is now really reusable, for instance, if you have a quad, you can do exactly the same. So you can also do the quad and attach an origin to it and extend the functionality of the quad without writing any additional code. And just to show you here the usage, you really can then just, for instance, on a triangle call something like translate origin, or on a quad call something like translate origin. And this is really a general piece of code. So if we, for instance, go here, we can just build the code, and we see that we have here, if this is our triangle, we have translated it here by 5, 5, and we see that all of the coordinates have increased by 5, 5. The same for the quad, and this is really something that makes this code very, very general. So in the wild, there are actually quite a few things where you could use this kind of pattern. So for instance, if you think about if you have something like a serializable interface, or some data that you want to push through a bus, or for instance, if you want to attach some debug functionalities to all of your classes, this is always a very good pattern to consider, because it's really just extending the classes itself without adding any overhead on that. So the next time you want to make something general, consider also this pattern, whether you might be able to apply it. If you do so, leave a comment below. Otherwise, if you want to keep watching, probably I have a video right there for you. As always, check out the code from GitHub, get your hands on the keyboard, and the most important thing, enjoy coding.